Welcome to MRL. In this learning session, we will learn the solutions of the circles exercise number 5.4 of 9th NCERT textbook Ganita Manjari. Now, in the previous session, we have learned the exercises from 5.1 to 5.3. Now, we will be learning the exercises from 5.4 to 5.6 in this learning session. Now, the first example of exercise 5.4, to prove that chords of a circle having the same length are all at the same distance from the center of the circle. The theorem is very simple. That means the chords which are equidistant from the center, the chords which are equidistant from the center are of the same length. That is the meaning of that. So, to prove that the chords of a circle having the same length are also at the same distance from the center, so chords which are equal in length are equidistant from the center, and that is what we have to prove. Now, let us take the circle with center C. Let us take the circle with center C, and before that, this theorem is there on page number 106, theorem number 6. It is proved. The same theorem is proved using the congruency of triangles, but here we have been asked to prove the theorem, the same theorem, using Pythagoras theorem. So let us understand how to do that. Now we are given a circle with center C. AB and FG are equal chords. AB and FG are equal chords, and we have to prove that equal chords are equidistant from the center. That means the chord AB is at distance CE and chord GF is at distance CH from the center, and we have to prove that CE and CH are equal. CE is equal to CH. Now for that, let us join BC and CF. Let us join BC and CF. Now CE is perpendicular to AB. CE is perpendicular to AB. Therefore, we have in the triangle BEC, that is BC square or CB square is equal to BE square plus CE square by Pythagoras theorem. That's what I have written here. CB square is equal to BE square plus CE square by Pythagoras theorem, because then again here CH is perpendicular to GF. CH is perpendicular to GF. That means again in triangle CHF we have CF square is equal to FH square plus CH square again by Pythagoras theorem. Now we know that the radii CB and CF are equal. That means CB square is equal to CF square. So we have got CB square is equal to CF square. LHS are equal. We can equate the RHS, and that is BE square plus CE square is equal to FH square plus CH square. But what we have to understand here is chord AB and chord GF are equal. Half of chord AB and half of chord GF are equal. That means AB upon 2 is equal to FG upon 2, and AB upon 2 is BE, and GF upon 2 is FH there, and square of BE is BE square, square of FH is FH square. That means BE square is equal to FH square. So therefore BE square and FH square gets cancelled, and what we get is CE square is equal to CH square. Square root, taking square root on both the sides, we have CE is equal to CH. CE is equal to CH, that is the perpendicular distance of the two chords from the center are equal, and that is what is the theorem to be proved. That means it's very clear the chords which are equal are equidistant from the center. So that is how we can use the Pythagoras theorem to prove this theorem, which is proved in theorem number 6 of page 103 using congruency of triangles. Remember that. Now coming to the next example, here we are given a circle with center C. We are given a circle with center C. CE is perpendicular to AB and CH is perpendicular to GF, and CE is equal to CH. So therefore we have been given the distance of the two chords are at equal distance, that is CE is equal to CH. Now we have to prove that AB is equal to GF. That means this is a theorem where the chords which are at equidistant are equal. That means the theorem is chords equidistant from the center of a circle are equal in length, and that is exactly the theorem what we have to prove, and that is theorem number 7, page number 104 of the textbook, and the proof of that theorem is given here. Now for the proof, let us join BC and GC. Let us join BC and GC. So when we join BC and GC, we get two triangles, right angle triangles. Rather, the triangle is BEC and the triangle is GCH. So we have two right angled triangles. Now in these two triangles, BC, okay, BC is equal to GC because they are radii, yes, they are radii, and CE is equal to CH, it is given to us. Angle CEB and CHG are equal to 90 degrees because CH is perpendicular to GF and CE is perpendicular to AB. Therefore, we have two right angle triangles here, and these two right angle triangles, by RHS congruency, the two triangles are congruent. That is, triangle BCE is congruent to triangle GCH. If the two triangles are congruent, then the corresponding sides are equal. Therefore, B is equal to GH. If B is equal to GH, then I can multiply by 2 on both the sides to get 2BE is equal to 2GH, and 2BE is equal to AB because we know E is the midpoint of AB. By when CF is drawn perpendicular to AB, we know that a perpendicular drawn from the center to a chord bisects the chord. Therefore, B is equal to AE, or 2 times B is equal to AB. That is correct. And same for the same reason, 2 times GH is equal to GF. Therefore, the two chords AB and GF are equal in length. So the conclusion is the chords which are equidistant from the center of a circle are equal in length, and that is the proof of the theorem number 7, which is given on page number 104 of the textbook. Okay, understand that. Now coming to the next example, now we have to solve the same question number 2 here. This is the question number 2 here. We have to again solve this or prove this by what we call as Pythagoras, by using Pythagoras theorem. Again, very simple. Let us see how to do that. We are given with given a circle with center C. CE is perpendicular to AB and CH is perpendicular to GF, and CE is equal to CH, and that is the two chords are equidistant from the center. Now we have to prove that the two chords are equal, and that is by Pythagoras theorem. Now we will do one thing. We will join BC and GC. When we join BC and GC, we get two triangles, the triangle GCH and triangle BEC. So we have got BEC triangle and GHC, two triangles we get, and in these two triangles, by applying Pythagoras theorem, BC square is equal to BE square plus EC square, CE square. BC square is equal to BE square plus CE square. So that is the first equation by Pythagoras theorem. And in the triangle GHC, we have got GC square is equal to GH square plus CH square, again by Pythagoras theorem. But what we know is BC and GC are radii, or BC square is equal to GC square. So BC square is equal to GC square, LHS is equal. Equating the RHS, we get BE square plus CE square is equal to GH square plus CH square. Now we know that B square is, please understand here, B square is equal to GH square. Please understand here that C is equal to CH is given to us, C is equal to CH is given to us to be equal, and therefore C square is equal to CH square. So C square and CH square get cancelled. We get B square is equal to GH square. So if B square is equal to GH square, square root of taking square root on both the sides, we get B is equal to GH, or 2 times B is equal to 2 times GH, and AB is equal to GF. And understand here, B is half of AB because E is the midpoint of AB and H is the midpoint of GF, and therefore 2 times GH is GF and 2 times B is equal to AB. Therefore AB is equal to GF, and that is what is the proof of the theorem, the question number 2, by using Pythagoras theorem. Remember that. Now coming to the next exercise, that is exercise 5.5 of the circles chapter, Ganita Manjari 9th standard NCERT textbook. In that first example is, we are given the circle with center O, the radius R, that is OA is equal to 7 centimeters, R is 7 centimeters. The distance of the chord from the center is 6 centimeters. We have to find the length of the chord AB. Again, now let us understand here, in triangle AOC, OA square is equal to OC square plus AC square, or R square is equal to D square plus L square. R square is 7 square, R square is 7 square, and D square is 6 square. So 7 square is equal to L square plus 6 square, or L square is equal to 7 square minus 6 square, or is equal to 49 minus 36, that is equal to 13. So we have L is equal to square root of 13. So we got L is equal to, L is AC. But C is the midpoint of AB, and therefore AB is equal to 2 times L, and that is 2 times root of 13 centimeter. Therefore the length of the chord is 2 times 2 root 13 centimeters. Okay, that is what is the question, and that is the answer. Now again here in the question number 2, we are given a circle with center O, and the radius is R, OB is the radius, and that is R, and the perpendicular distance of the chord from the center OC is D. Now we have to show that the chord length AB is 2 times square root of r square minus d square. So let us understand how to do this. Now if you take the triangle BOC, then OB square is equal to OC square plus BC square. That means OB square is r square there, r square is equal to OC square is d square plus BC square, and BC square is equal to r square minus d square, or BC is equal to, taking square root on both the sides, BC is equal to square root of r square minus d square. But we know that C is the midpoint of AB because OC is perpendicular to the chord, and therefore C is the midpoint of AB. That means BC, 2 times BC is AB. So taking 2 times BC, it is AB. I am multiplying both the sides 2. Therefore 2 times BC is equal to 2 times square root of r square minus d square, or AB is equal to 2 times r square minus d square, and that is exactly what has been asked to prove, and we have proved it. So that is how we have got the answer, 2 square root of r square minus d square, that is the length of the chord. Now let us go to the next example. We are given here, we are given a circle with center O. AB and CD are the chords. Distance of chord AB from the center is 2 times the distance of the chord CD from the center. That means the distance OM is 2 times ON, or OM, if ON is D, then OM is 2D. Now what we have to find is whether the chord CD is also double the chord of double the length of the chord AB. So now we have to check whether it is if the distance is double, then whether the chord CD is twice chord AB, and that's exactly what is been asked here. Now what we will do, join OA and OC. Let us join OA and OC, and let us try to find out the CN and AM. Let us see how to do that. Join OA and OC. So we get 2 triangles here, AOM and AOM. Okay, in triangle AOM we have OA square. OA square is equal to OM square plus AM square by Pythagoras theorem. And putting the values here, OA square is r square and OM square is 2d whole is to square plus AM square, or AM square is equal to r square minus 2d square, or AM square is equal to r square minus 4d square, and that is the first equation. Now taking the triangle CON, OC square is equal to CN square plus ON square, and putting the values, OC square is r square, ON square is d square, and CN square, so CN square is equal to r square minus d square. That is the equation number 2. Now if I divide CN square by AM square, so I take CN square divided by AM square, take the ratio, CN square by AM square is equal to r square minus d square divided by r square minus 4d square, and taking the square root on both the sides, we get CN upon AM is equal to square root of r square minus d square divided by square root of r square minus 4d square. Now CN is half of CD, so I can take, if I multiply by 2, that is 2 CN will become CD, therefore I have multiplied by 2 here, both the sides. So 2 times CN upon 2 times AM divided by 2 times AM is equal to 2 times square root of r square minus d square divided by 2 times r square minus 4d square, 2 cancels there. But where is 2 CN is CD and 2 AM is AB, so we got CD upon AB is equal to square root of r square minus d square divided by square root of r square minus 4d square. Now if you look at the RHS, the value of the RHS depends on the radius of the circle and the distance of the 2 chords from the center. Therefore the value is not 2 at all. Therefore CD upon AB is not equal to 2. If it is not equal to 2, then there is no question of CD becoming twice AB. So therefore the CD is not equal to 2AB, or CD is not necessarily twice AB. Maybe under certain conditions of R and D it can be double, but as such it is not equal to 2, and therefore it is not double. The chord CD is not twice the chord AB. Okay, although the distances are double from one another. When we checked here, the distance of AB is 2 times the distance of the chord CD from the center, but the lengths are not double. That is, CD is not double the length of the chord AB, and that is what is the proof of this particular example. Try to understand that. Now coming to the next example, that is exercise number set 5.6 of the circles chapter, Ganita Manjari, 9th standard NCERT textbook. Now what we are given here, we are given a circle with center O, angle AOB is given as 60 degrees. Now radius is 12 centimeter, that means OA is 12 and OB is 12. Now we have to find out the length of the chord AB. Now if we check this triangle AOB, angle AOB is 60 degrees, OA is equal to OB, OA and OB are equal because the radii, automatically the angle A and angle B must be equal because angles opposite to equal sides are equal. If this is 60 degrees, then 60 degrees plus angle A plus angle B is 180, and that is but angle A is equal to angle B. Therefore 60 plus 2 times angle A is equal to 180, or angle A is equal to 60 degrees. If angle A is 60 but natural angle B is also 60 degrees, the three angles of the triangle AOB are equal. That means triangle AOB is an equilateral triangle. If OA is equal to 12, OB is equal to 12, AB is also equal to 12 centimeters, and therefore the length of the chord AB is 12 centimeters. Okay, it's a very simple example. You can easily understand that. Now coming to the next example, we are given a circle with center O. A and B are any 2 points on the circle. Now we have to find out if x and y, we have there are to find the points x and y such that where the points x and y such that the angle AXB and AXB and AYB are different, such that angle AXB is different from angle AYB. X and y are on the same side of A and B. Now the question is to find points x and y, such that angle AXB is different from angle AYB, and x and y are on the same side of the points A and B. So now what is the question is, if we have a circle with center O, if there are 2 points AB on the circle, then we have 2 points x and y on the circle on the same side of the points A and B, and is it possible that AXB and AYB, the two angles, are different, or are they equal? So that is what we have to prove here. Now let us understand, if angle AOB, central angle AOB, because RKB is there, it's a subtended angle AOB at the center. If I take it as 2x, then angle AXB is the angle at the circumference subtended by the same RKB. If this is 2x, then angle AXB is x. And also AYB is also standing on the same arc, therefore angle AYB is also equal to x. Therefore the points x and y, which lie on the same side of the points A and B, are equal angles, that is AXB is equal to AYB. That means the two angles AXB and AYB are not different, they are 100% same or equal angles. Now the question is, x and y are lying on the same side here. Now the question is, if x and y, please understand here, if angle AXB and AYB are equal, then x and y lie on the same side of AB, and it is true. Provided AB is not, if AB is not the diameter, x and y will lie on the same side of AB if AB is not a diameter. Supposing if AB is the diameter passing through the center of the circle, then x and y can lie on either side of the diameter or on either side of the line segment AB, and that is what is the meaning of that. Now if AXB is equal to AYB, if angle AXB is equal to angle AYB, then x and y do not lie on the circle. Let us assume that x and y do not lie on the circle. Then is it possible that angle AXB is equal to AYB? If x and y do not lie on the circle, it is not possible that AXB and AYB are different. They are definitely equal. Now so the circle through ABX and will also, the circle through ABX will also pass through Y, as ABXY are concyclic. Angle AX, because angle AXB is equal to angle AYB. The central, if AXB is equal to AYB, the central angle is the same, and if the center angle is the same, and the center also will be the same, and therefore AXYB are concyclic, and the circle will pass through all the 4 points. So try to understand that. I think you have understood what I have spoken. So please go through whatever I have written here, read it, you will understand it better. Okay. Now coming to the next example, that is the third example. Now we are given a circle with center O. ABCD is a cyclic quadrilateral. Angle ADC is 100 degrees. We have to find the angle x here. But we know that in a cyclic quadrilateral, the opposite angles are supplementary. That means angle ADC plus angle ABC is equal to 180. That means angle B plus angle D is 180, or x plus 100 is equal to 180, or x is equal to 180 minus 100. Therefore x is equal to 80 degrees. So that is such a simple example. So all these examples which I have discussed are not very difficult. You have to understand the basics, apply those basics, and solve the examples, and learn the basics thoroughly, then only the solving examples will be easy. And without knowing the basics, it definitely will you will feel it difficult to solve the examples. So learn basics, apply your complete energy in learning the basics itself, and then apply that knowledge to solve the examples. So please note down these in a book and keep them as a reference for your future use. Okay, thank you.